Hello and welcome to Call of Chemistry. By this video, we are starting Organic Chemistry, some basic principles and techniques chapter of class 11. I am trying to cover up this chapter by 5-6 separate videos. So let's start. So in order to learn organic chemistry, we have to understand the bonding of organic compounds. Organic compounds contain covalent bonds such as sigma bond and pi bond. So what are sigma bonds? Sigma bonds are formed by head-on overlap of atomic orbitals. We'll understand by some examples. SS overlapping, suppose it is an 1s atomic orbital and it is another 1s atomic orbital. And if these two orbitals overlap head on, it will form these are the two electrons, and this is called SS overlapping. Head on overlap take place here, and this forms SS sigma bond. Another example is sp overlapping. Suppose this is an 1s atomic orbital which overlaps head on with an 2p atomic orbital. This is 1s and this is 2p. Head on overlap take place and we get these are the two electrons. So this also head on overlap, and this is a sp sigma bond. Another example of head on overlap is pp overlap. Suppose a 2p atomic orbital is here and another 2p atomic orbital, consider it is 2p and it also 2p, and upon head on overlap this pp sigma bond is formed. This is pp overlapping. These are the two electrons. This also a head on overlap, and we get pp sigma bond. Next, we will discuss about pi bond. Pi bonds are formed by lateral overlapping of p or d orbitals. We will understand by some examples. Suppose a 2p atomic orbital is there. This is 2p, this also 2p. And upon side lateral overlap, this formed. Or you also can draw like this. This shows the pi bond and also shows the lateral overlap. And by this lateral overlap, pp pi bond is formed. We all know carbon is tetravalent. Now this tetravalency and formation of covalent bonds by it are explained in terms of hybridization of s and p orbitals. Now we will understand what is hybridization. So hybridization is basically concept of mixing of atomic orbitals of slightly different energies, and upon mixing of atomic orbitals we get new orbitals of equal energy and identical shape. There are some important points regarding hybridization. Those are number of hybrid orbitals formed is equal to number of atomic orbitals that participate in hybridization. Next point is, as a result of hybridization, only sigma bonds are formed. Pi bonds never formed by hybridization. That means upon hybridization, head-on overlap between atomic orbitals take place. That is why sigma bonds are formed. As we know, pi bonds are formed by lateral overlap of atomic orbitals, and as hybridization takes place via head-on overlap, so there will be only sigma bonds are forming upon hybridization. Next point is size of hybrid orbitals decreases with increasing S character. So this is sp3 and the order will be size of sp3 orbital will be greater than sp2 than sp, as S characters for sp3 hybrid orbital S character is 25% and for sp2 it is 33.3% and for sp it is 50%. Now how can we calculate S characters? For sp3 1s orbital overlaps with 3p orbitals. So S character will be here 1s orbital is there and number of total atomic orbitals is 4, 3p and 1s. So 1 upon 4 into 100, so 25%. And if we calculate the p character, so there are 3p atomic orbitals, so 3 upon 4 into 100, that is 75%. This is how we calculate the S character and p character. So it will be sp3 csp3 greater than csp2 csp2 greater than csp. So we can find that size of hybrid orbitals decreases with increasing S character. So as size of hybrid orbital is maximum for sp3, so cc sigma bond length will be maximum for csp3 and csp3 sigma bond and minimum for csp sigma bond. Now shorter the bond, greater is the bond strength. So bond strength order will be shorter the bond, greater will be the bond strength. So bond strength order will be CSP greater than CSP2 greater than CSP3. Similarly, we can write that bond strength order CSP hydrogen greater than CSP2 hydrogen greater than CSP3 hydrogen. Here sp hybrid orbital of carbon overlaps with 1s atomic orbital of hydrogen and forms CsP hydrogen sigma bond. And also here similarly sp2 hybrid orbital of carbon overlaps with 1s atomic orbital of hydrogen and forms CsP2 H sigma bond. Here also sp3 hybrid orbital of carbon overlaps with 1s atomic orbital of hydrogen to form CsP3 H sigma bond. Next point is with increasing S character, electronegativity of the atom involved in hybridization increases. That is, electronegativity order will be CsP, CsP greater than CsP2, CsP2 greater than CsP3, CsP3. This is electronegativity order. Now we will discuss about different type of hybridization in organic compounds. Firstly, we will discuss about sp3 hybridization. The example of sp3 hybridization, the compound is methane or CH4. So valence shell electronic configuration of carbon is this is 2s and this is 2p. So 2s2, 2p2, and this is ground state. If we add some energy to the system, it will be reach in excited state, and one electron from 2s jumps to 2p. This is excited state. Then hybridization takes place, that is sp3 hybridization. In sp3 hybridization, one 2s orbital overlaps with 3 2p orbitals and gives 4 sp3 hybrid orbitals. We previously discussed that number of atomic orbitals participates in hybridization is equal to number of hybrid orbitals formed. So here we can see that 4 atomic orbitals involves hybridization, so we get 4 sp3 hybrid orbitals. And total electrons are 4, so it is distributed such way. Then one sp3 hybrid orbital overlaps with 1s atomic orbital of hydrogen and forms a sigma bond. This also overlaps with 1s atomic orbital of hydrogen and also forms sigma bond. This also forms a sigma bond and this also forms a sigma bond. So if we draw the methane, this is sp3 1s sigma bond, this also sp3 1s sigma bond, this also sp3 1s sigma bond, this also sp3 1s sigma bond. Now we will discuss about sp2 hybridization. Example of the organic compound with sp2 hybridization, that is ethylene. So valence shell electronic configuration of carbon is, this is 2s and this is 2p. There are 2 electrons, here also 2 electrons, that is ground state. And if we add some energy to this system, it will reach to excited state, where 1 electron of 2s jumps to 2p. Such way, this is excited state, and then sp2 hybridization takes place. In sp2 hybridization, one 2s orbital overlaps with two 2p orbitals and forms 3 sp2 hybrid orbitals. The number of atomic orbitals involving hybridization is 3. So number of hybrid orbitals formed will be also 3. So three sp2 orbitals and a 2p orbitals remains. This is 2p. And electrons are distributed as follows. Now this sp2 hybrid orbital overlaps with 1s atomic orbital of hydrogen to give a sigma bond. This also overlaps with 1s atomic orbital of hydrogen and forms a sigma bond. This overlaps with sp2 of another carbon to form sp2 sigma bond, and this overlaps with 2p of another carbon to form pi bond. So if we draw the ethylene compound, the pi bond is here. So this is sigma, 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 and this is pi. Actually, this is sp2-1s sigma bond. This also sp2-1s. Similarly, this also sp2-1s. This is sp2 sigma bond, and this is 2p pi bond. If we draw the orbital picture, so here is an sp2 hybrid orbital, here also an sp2 hybrid orbital, and the third sp2 orbital overlaps with another carbon. This sp2 hybrid orbital overlaps with 1s of hydrogen. This also 1s overlaps with 1s of hydrogen. This also overlaps with 1s of hydrogen, and this also. Now this carbon has a 2p orbital, and this carbon also has a 2p orbital. And this is the pi bond. This is pi bond, which is formed by lateral overlap. These are sigma bonds formed by head-on overlap. This is actually sp21s sigma. This is sp21s sigma. This also sp21s sigma, and this also sp21s sigma, and this sp2 sigma, and the pi bond is 2p pi bond. So this is the orbital diagram of ethylene. Now we will discuss about sp hybridization. The example of sp hybridization that a compound possesses, that is acetylene. So valential electronic configuration of carbon contains 2s2 2p2. That is ground state, and if we add some energy to this system, this will reach the excited state, where one 2s electron jumps to 2p. After that, sp hybridization takes place. In sp hybridization, one 2s orbital overlaps with one 2p orbital to form two sp hybrid orbitals. So here number of atomic orbitals participating in hybridization is 2. So number of hybrid orbital formed is 2. So here it is sp and it is sp. Two sp hybrid orbitals are there. Remaining two orbitals are 2p orbitals. So here will be 1, here will be 1, and remaining 2 electrons are there, is 2p. Now this sp hybrid orbital overlaps with 1s of hydrogen to give a sigma bond. This overlaps with sp of another carbon to form a sigma bond. These two 2p electrons overlap another two 2p orbitals of another carbon to form two pi bonds. And if we draw the orbital picture of acetylene, this is 2sp hybrid orbital of one carbon, and this is the another carbon. And this carbon has two 2p orbitals. One 2p orbitals is like that, and another is such a way. So if we draw the pi bond, this is one pi bond, and that is another pi bond. Yeah, it is 1s of hydrogen, also 1s of hydrogen. So this is sp1s sigma bond, and this is also sp1s sigma bond. This is sp sigma bond, and these are two pi bonds of 2p2p. So this is the orbital diagram of acetylene. Now we move on to the next topic, which is structural representation of organic compounds. Let's consider the molecular formula. This is the molecular formula. Now this can be drawn in the following representations. That is, one can draw like this way. Here is H, here is CH2, and it is the complete structure. This can be drawn another way by this. This is called the condensed structure, or this is called the bond line structure. In bond line structure, this terminal represents methyl groups, and this represents the methylene group. This is methyl. So by this I am stopping here. If you have any doubt, please let me know in the comment section. Please like, share and subscribe my channel. Thank you.